in the Zoom, and the other one will be given a presentations online. Yeah, so stay tuned. We will start very soon. I think for these sessions will last for an hour. We will have plenty of time, for Q&A and all these. And I really don't fuss on using the whole hour. I know all of you have been enjoying a long speech this morning. Yeah, so I will just, just give it a go, for having all these flow very comfortably. Yeah. Okay, 2 minutes to go. This is how we do the hybrid teaching in the past semesters. And the attendance is more or less the same.
For a class of 320.
For a class of 300 students.
300, okay.
You're looking forward to getting back to face-to-face?
I think they would get ready to study in their office. It is a new norm. All the students, it's just crazy. As you heard the speech today, yeah, it's just because there are too many jobs in Victoria right now happening. Most of our students get hired when they study year 2.
Yeah, but most of our students are coming over here too as well.
I try not to say that. Yeah, you just tell me that I will block them. Okay, 1 minute to go. So welcome all to these sessions. And we have our first presentations. Maybe I can right now give some introductions of the first speaker. We have Raymond as the first author, but I think today's the presentations will be given by Associate Professor Keyao. And the topic is real-time employee monitoring technologies in the construction sector, effects, readiness, and theoretical perspective, the case study of New Zealand. And so let's welcome Ken. We will start today's first presentation sessions. Over to you, Ken.
So can everyone hear me online? Yeah, okay, thanks. Good morning, my name is Kenneth from School of Built Environment, Massey University of New Zealand. Today, I will talk about one of my research projects in employee monitoring technology in construction site. For this paper, is a joint paper with my PhD student Raymond, who is now online, and Mostafa here. And we would like to share with you about the preliminary findings for this project. Perhaps I would like to take this chance to acknowledge the funders of this project. This project is funded by grants, Building Research Association New Zealand. And the title of this project is to study the ethical, legal, and behavioral concern of construction workers or employer for real-time employee monitoring. So I am the lead researchers for this project, and we have group members for key researchers, including Raymond, Associate Professor Lassim, Reno, Mostafa, Raymond from Auckland University of Technology and University of Canterbury, Brian. So I'd like to acknowledge their contribution for this project. Perhaps I would like to give you some background why this project can be funded by grants. In the construction sector, in New Zealand especially, employee monitoring actually is not that well received, in the sense that there will be a lot of concern from the workers or from the employer. Say we impose a lot of questions to the industry, say if you would like to set up a set of monitoring tools in the construction site, what are your concerns? What you need to consider in order to protect the privacy of the workers. There would be a lot of questions in the construction workers about employee monitoring. Currently, we have some worker trackers are available in construction sites. They use the GPS. it's not that popular, but as workers, I still have concern of using that, especially when your employer asks you to bring those GPS tracker to home for charging, to charge battery. You know, they will concern, they say after office hour, my employer know where am I? So there will be a lot of concern. That's the reason why brands would like to support us. $150,000 to prepare to work on this research project to identify the ethical concern, legal concern, and behavioral concern for employee monitoring at construction site. So this project is not going to test any employee monitoring technology. It's about behavior, about workers, about privacy. So there are two stages of project. The first stage is to understand more about employee monitoring, and we hope to develop a guideline for construction workers and the construction employer, okay, to give them an idea, say, if you want to impose monitoring tools in the construction site, what should you do? So the first stage, we are working on that, development guideline, understand our EMT. And the second stage is that we would like to do some trial in the sense that make use of the employee monitoring technology in the construction site, and then try to apply and evaluate the developed guideline to make sure that the guideline is feasible, is workable. So this is the general introduction for this project. So we adopt a very, very traditional construction management technology to conduct this project. Firstly, literature review, and then we do have two focus groups. As you can see in the second slide, we have a lot of icons. You know, some of them are the construction lawyers, some of them are from the contractor, developers. You know, they are the key stakeholders in the construction industry. So we conduct two focus groups, you know, to them to understand what they want, you know, to develop something on the guideline. And then we have a questionnaire survey, a very traditional one. A questionnaire survey to understand their concern, to study their readiness to be monitored, you know, in the construction site. And then we also aim to develop some theoretical framework, you know, to incorporate some theory, especially not from the construction area, maybe from psychological, social science, about privacy or behavioral changes to apply on this project. And then we finally definitely will hope to make use of the guideline, promote it, try to use it in the construction industry. So the next slide will be presented by Raymond. Raymond, can you hear us? Hi, Raymond.
So hello.
Yep.
Can you guys hear me?
Yep.
Yeah, that's a difficulty for technology adoptions, as my audio cannot be delivered to your site correctly. Yeah, I'll just have a quick review of my preliminary result of this research. One of the important the methodology we have been using for this project is using the nationwide questionnaire survey. So since last July, we have been received 236 set of data from New Zealand-based construction sector. And 44% of those respondents are frontline workers, who is our potential group to be monitored in the future. And we have been find out the age of the participant and work experience in the construction industry are the factors that need to be considered. Most of our respondents, say 70% of our respondents are middle-aged workers. They are from age 25 to 45. Well, once we got those data in hand, we are using the relative importance index to prioritize those positive and negative effect. We have been using different questions to testing their respondents about real-time employee monitoring at their work site. As shown in this pan chart, the 27% of respondents had some experience being monitored. And 36, they have no experience at all. And 37, they have no knowledge of what is employee monitoring. And also showed in this table, as mentioned earlier, we have been using RII to prioritize those effects. The top 5 has been identified. And also those negative effects are provided us more information to illustrate the concerns of construction sectors of those technologies. For example, the users need to fully understand the purpose of the monitoring and their legal and privacy rights, how well those employers using their data, and also the impact of those technologies to the workers' well-being. Can you move to next slides?
Yep.
Yep. The last one. I've been got a little bit of different slides here, but the result above showed over
An update one.
Yeah, the 70% of the participants have rated more than 5 on the Likert scales, and they are holding a relative positive attitude on this employee monitoring, which installed in their worksite. And generally, we say they are ready to be monitored if the employer or authority required. And we got 5 different readiness questions. The general question is, are you ready to be monitored? And this question got second high mean scores, which is 4.93 out of 7. And the second question is the positive questions. I believe employer monitoring increased work efficiencies at the construction site. This question achieved the highest mean scores. And in the other question we have been found is interesting is the question asked, I accept the trade-off some of my privacies for a company's collective interesting. This question also achieved quite high scores. And this one showed the positive side on the willingness to be monitored for business purposes. And interestingly, the participant relatively consider the employer might over-control the project through the RMIT using the technologies, which we have been found 35% of them was rating this Likert scale less than 4. So people are concerned about their employers or contractors over-control the project using this technology. And in addition, according to our literature reviews, we have been designed these questionnaires by 5 possible influence factors. You know, they are age and the monitoring experience, understanding of RMITs. This one we have been grouped as tangible factors and to influence the user's perspective on the adoption of the technology. And we have been find out through the survey, the younger age of group and people with the monitored experience showed higher acceptance levels in New Zealand basis. Also, they have presented a better understanding of monitoring technology. However, there are some intangible factors we also find out affecting those technology adopted at the construction site, including building company's culture and industry ethical standard, trust between contractors and workers, and work commitment, and also some behavioral patterns. And this research also showed that the tangible influence factors are weighed more than the intangible factors. But for our project, we are going to focus on those intangible factors. As Ken mentioned earlier, we are going to focus on the behavioral patterns or some other factors can influence in this technology adoptions. And for the future study, I will let Ken to illustrate more about that. Thank you, guys.
Thank you, Raymond. For the future research areas, so we are planning to develop some theory based on these 3 popular theory. Say for the equity theory, say for example, if someone is being monitored, there will be some undesired behavior from the worker. So we need to try to track the response. And also communication privacy management theory is try to test the privacy boundary of the workers. Say some of the previous studies show that if the employer would like to discuss with them informally about their privacy boundary, then can help the situation. And control theory of privacy, it means that privacy is determined by the ability to control personal information. Control personal information is the key to protect the privacy. And then, as I mentioned, we need to develop the guideline. We need to do a trial application for the developer guideline. So that will be the common plan for this project. So that's all for the project. We're very happy to take some of your questions. Before the Q&A session, we'd like to do one promotion, two promotion here. Is that I am the managing guest editor for safety science. So it's about the use of technology on controlling health and safety. And the deadline will be in October 2022. So please do have a look and submit a paper to this journal. Another one is about the ASC journal. I'm also the guest editor for this ASC journal on the use of the technology based on legal and concerns, something like this. So welcome to submit a paper. If your paper is focused on legal perspective, ethical perspective, welcome to submit to this ASC journal. For safety, welcome to submit to health and safety. Anyway, thanks for that. Thank you.
Thank you, Ken. I think we need to do something for ICE and put a page in there. But anyway, thanks for the presentations. Very interesting one. I would just like to ask the audience in here, would you have any questions to ask to Ken and Raymond? Hi, Fred.
Hi, firstly, I sincerely apologize for being late to your presentation. I was super excited to be here. I did not realize 11 o'clock was across the board and was expecting to be told something else. So apologies to start with.
Don't worry.
And thank you very much. My question is partly about the empirical work, and it may be something you're going to reflect on going forwards. How did you account for the workers and their sort of very positive responses, given the power relations at play between worker, employer, and also researcher to some extent, and how the employer-researcher relationship may be seen by the workers?
Raymond, do you have any idea on this? Oh.
So it's just how you've accounted for or explored or made acknowledgement of that power dynamic within this body of people that your sample, basically.
You mean in the sample?
For the empirical work. So you've asked them, do you want us to do this? And they've said yes. Okay, that's not, it's to do with that power relationship about fear of job continuity, job losses, and things like that.
Yeah, that's right. Yes, it's one of the concerns the workers have when we're doing the surveys, and some of the workers concerning of their relationship with their employers. And we have been taking this one, survey absolutely anonymous, and we ask employers to not disclose any information of their workers, and also for the future use of the technologies, we are fully considerate of the Privacy Act in New Zealand, and we have give them like on the basis of the information was absolutely not been disclosed to the third party.
Okay, thank you. I fully accept all of that, but it's how much people believe you, given how we know data has been used by Instagram, by various large technology companies. There is the potential for this anonymization, but there's also the potential for the digital exhaust and other elements to actually completely undermine that in practice. So I with work like this, I'm always very keen to see how you've explored and managed that. So thank you for your answer.
That's great. I think that's one of the purpose with developing the guidelines. The guideline is for both of employers and employees to understand their rights and understand their privacies and understand how the data being managed during the research.
Thank you.
Another concern from the worker is that some of the worker actually is afraid of the data, the monitoring data being used for performance review. So we need to be very cautious on this to make sure that we develop some guidelines to help.
Or we could not do it, just saying.
Yeah, thank you. Power relationship is always a concern for many people, in particular for the ethics committee. And so I would really appreciate that project still can go through. Yeah, and we have another questions here from the audience, and then we will have one questions online. So stay tuned, Claire.
Yeah, just further to that question before, is the data going to be cloud-based? Because if it's cloud-based, you cannot give any reliability at all. We're staying, all of us are staying here at the Scarp Aurea Hotel. And have you noticed the technology that's in that hotel, that they actually know where you go, what time you go, how the lifts are going, and they monitor everything that you're doing in that hotel? Put aside the idea of Fitbit and sleeping patterns, which are cloud-based, which are being used by other third parties to understand what sort of products should be sold to certain people. So how can we give any sort of confidence to people on these sorts of monitoring data at all? That's first part. Second part is, what's in it for the people being monitored? Do they get a pay rise? Do they? What's people being monitored? Do they get a pay rise? Is it just because they want to do better for the firm that they are having a Likert scale of 5.09?
Thank you. Over to you.
Thanks for your questions. This is the purpose why we need to have this project. Actually, we don't have any clear instruction to everyone. But when we buy a Fitbit, when we buy a Apple Watch, the first time to switch it on, we need to click a lot of things. You know, there are a lot of small claims there that you are agreed to be monitored for some extent. So we hope to develop something similar in the construction site. So when people are working in the construction site, they feel comfortable to be monitored based the fact that we need to have a developed guideline to make them comfortable. But it's a long way to go, honestly. Yeah. Any about Raymond?
Yes, I'll answer the first question from Reagan. I don't know, but the first question is about is that cloud technology. The monitoring technology at the moment is cloud-based, and there are strict confidentiality agreement between the software suppliers with the users of the technology. And the cloud have, for one of our products, we trying to use, they have 3 different type of firewalls to protecting the data leakage or information leakage. The second question about how the workers if they can get their pay rise or something. I think this is a kind of agreement between employers and employees. They're going to be writing in their employment agreement or contract agreement. The main purpose of the monitoring technology is for safety and productivities. If the employer agree this technology can improve their productivities or safeties, they will have a detailed information writing in their agreement. Thank you.
Yep. Thank you, Raymond and Ken. And yeah, I'm really aware of the fact that right now we have 6 minutes behind. But for all those audience in here, you're also encouraged to maybe get into online, because we have some questions from the attendees online, and from there then you can also find some of the responses from the speakers. So at the same time, Raymond have already answered some of the questions being asked by the audience online. Yeah, but feel very sorry for time being limited, so I will just leave it in here and leave it to the second speakers of presenters of today, which is Eden. Yeah, so thank you, Ken. Thank you, Raymond. So we have Eden here to present the second paper that's entitled Building a Data-Driven Future for Construction Team, Capabilities Matters. And so, yeah, I think it's helping. So over to you, Eden.
Hi, everyone. Hi, everyone. My name is Eden. I'm a postdoc researcher from the Curtin University. It's a great honor to be here in person to present the study. And it's just a great honor to be able to travel again after a couple of years disruption because of the, So it's good to be here to present a study with the title Building a Data-Driven Future for Construction Team Advantages Matters. Yeah, before we start, I would like to give a brief introduction of the research institute I come from. Future of Work Institute includes Center for Transformative Design at Curtin University. We promote important work and meaningful work as essential for building a healthy economy and society. We have a renowned research team in the future of work. We cover a wide range of academic and industry expertise with the collaboration with both private and public sector organizations and employees. And researchers in the Future of Work Institute focusing on understand how people could benefit from and contributing to the global economy and how we support thriving organizations in the digital age. The research directions in Future of Work Institute include transformative work design, work capabilities and motivation, human system integration, public policy in digital age, data analytics decision making, and aging and work. Future of Work is also a member of ARC ITTC Center for Transforming Mentions through Data Science. Next, please. I think we can all agree with the fact that the world is changing and it is changing fast. As the unprecedented COVID-19 caused some profound disruptions to the global economy, it has been fundamentally accelerated the shift to a digital future, and emerging technology have been generating huge amounts of data and have huge potential and leading to increasing risk of data science field. Construction industry is no exception, with studies demonstrating the huge potential of using data-driven project management platforms in terms of reducing project costs and completion time. As this morning, our first keynote speaker talking about the importance of using project management forms and how the Office Project Victoria has been reporting 379 projects have been overrun over like 59%, and almost 1/3 of project has been ongoing exceeded estimated schedule time. So if we have data-driven project management platform could help us to reduce the project cost and completion time, that will be huge potential. So it is important to use data-driven analytics technology. Correspondingly, there's increasing need to understand the skills and the requirement required for the construction community to better release the power of data. Next, please. Previous studies have been identifying the challenges against the better use of data in the construction community. Key factors include data security issues, poor data quality, inadequate equipment on site, and technology difficulties and technology issues. Beyond technology issues, there's still lack of trust, lack of data awareness, also the resistance to changes. Among all of these factors, talent and skill shortages is one of the formidable factors which could underline and lead to any other factors. Many digital transformation guidance suggested that we need a digital leader to drive the from top to bottom organizational changes to promote data science innovation. However, it remains unclear what does a digital leader in construction industry should have, what other skills, capabilities required for those leaders to promote data science innovation and promote the use of data. Next, please. Construction project manager play a critical role in construction industry to ensure a successful delivery of construction project. And their responsibility cover a wide range of activities ranging from determining work scope, allocating resources, assess quality safety, coordinate project, connecting multiple stakeholders, and build team model. Positive link between the competence of construction project manager to general team performance have been identified. So construction project manager have been found contributing to improve project performance, project-based relationship, realization benefits management, and optimize project planning and promote team knowledge. So there's potential for construction project manager to become the digital leader in this data-driven science to promote the use of data in the construction community. As current studies about the competence and the capability of construction project manager focusing on the general competency, how they could contribute to successful project delivery. So there's limited understanding towards what are the skills capabilities required for those construction project manager to build a data-driven team, how to improve the use of data within and across teams. So based on the current literature on general competence and considering the role of digital leader in driving from top to bottom organizational changes to promote innovation, we propose a list of data-driven capabilities required by construction project manager. Examples include having a good understanding about the available data set and know how to get access to it, be able to effectively use data devices to manage information, be able to adjust and adapt quickly when organization changes happen, when they use new tools, be able to quickly learn new skills and changes and adapt to changes in core work tasks, and keeping a problem-solving mindset. The full list of capability list can be found in the comments below. So the aim of the study is try to understand what are the skills and capability required for construction project manager to lead a data-driven team to improve the use of data in the project. We developed a questionnaire study for this study. It includes 3 parts. The first part, we try to collect the demographic information of the participants. Second part, we collect the general team usage and general data awareness in the team. The third part is a peer evaluation towards how the project manager demonstrating the list of data capabilities revised based on literature. In total, we distributed 374 questionnaires in China, and with the 290 well-engaged responses, yielding a response rate of 77.5%. And the random distribution, we have 56.2% are male. The rest are female, standing for quite a balanced profile, considering construction industry is quite a male-dominated industry. Measures, we use 3 items to measure the data usage in the construction team. A sample item is, in general, is a team aware of the importance of available data. And we use 17 items revised based on the literature to assess the data-oriented construction project manager capability. We use the non-parametrics Whitney U-test and Cookie Willis H-test to test the differences between different groups in terms of gender, professional background, and expertise. And we use Pearson correlation to test the relationship between the team use of data and construction project manager capability. In terms of the findings, in terms of team data usage, there have been no significant differences found in different groups, in different gender professional groups. However, construction project manager with longer working experience are shown leading better teams in terms of using better data. So working experience still matters, huh? In terms of the relationship between team data usage and the construction project manager capability, the top 3 capability which were found strongly correlated to project team data usage include keeping a problem-solving mindset, ensuring that basic tasks to be completed at a high level of proficiency, and maintaining a high ethics standard when capturing using data. I found the research findings quite intriguing in a sense. The key capabilities required for construction project manager are not technical skills, are not technical capabilities. Instead, they are cognitive skills such as problem solving, and they are foundational skills with a notion that only if people could do basics well, only if people could excel at basics, innovation could be possible. So these research findings lead to our future research direction. Okay. So the first, we want to build a comprehensive data capability framework required for construction project manager to manage a data-driven team and improve the use of data in the team. Another perspective to understand capabilities coming from organizational level perspective. We introduced a term called data fit organization, standing for organizational level dynamic capability to be mature in the digital age. I personally quite like the term data fitness. It's like physical fitness. This is something you can work on and improve. Like as an organization, in order to become data fit organization, we need mature data infrastructure. We need well-defined data roles, clearly identified role clarity, and ability, skills, knowledge associated with those roles to enable them to be effectively collaborate together and developing partnerships. So in particular, the role of construction project manager play as a digital lead should be important to understand what exactly required by them to support the innovation in the organization. So this pivot exploratory study should provide insight and attract more attention to future researchers' studies related to data science innovation in the 20th century to build a more mature digital future in our community.
Thank you, Eden.
Involved in the study. Any comments, questions are welcome.
Thanks, Eden. Very interesting presentations again. Yeah, with the time limitations, I would just constrain the questions into two. Might be, is there any questions we'd like to raise?
Thanks for the talk. Can you go back to the second last slides where you're showing the tasks, so the capabilities that project manager should have? I think the second last slide. Previous one. Here. So how did you work out those numbers like R and P values for these three capabilities?
Yeah, this is the Pearson correlation. So we, in the questionnaire, we have the last two parts. We have asked the people to peer evaluate the construction project manager behavior according to the list of capability provided based on literature review. And then on the other hand, dependent variable, we have the general team usage and the team data awareness. So this is the Pearson correlation.
Thank you. It looks like the results are quite significant. Yeah, even though the relationship might not be as strong, but it's a significant results. Any further questions? We can have one more. Thank you.
Thanks for the presentation. In this movement to like data-driven paradigm, do you see eventually you'll take a top-down approach or bottom-up approach? For example, in Victoria, we now have the Victoria Digital Asset Strategy, pretty high level, but it's trying to formulate that top-down structure. So what's your opinion on this?
Yeah, I think this is a very interesting topic. As in, from an organizational psychology point of view, I think innovation should be driven from both sides, so either top-down and bottom-up. So we need to drive from both the top management level, also the innovators, the key innovators, and the key employees. So our theory is that we believe in terms of promote whole organization innovation, we need the effort from every member in the organization. The key concept of data-fit organization is saying that every individual in the organization have a data role to play. The role is unique and each role is important. So only if everyone have an awareness of using data, have the proactive and being adaptive in those changes, innovation could happen. So simple answer is we know we need both top to the bottom and the bottom up innovation together.
Thank you. So thank you, Eden, for the very interesting presentations. We have a third one, which will be presented by Kambiz. Kambiz is going to present to us a paper entitled Design Analysis of Real-Time Progress Tracking System, Practical Case Studies. Over to you.
Good morning, everyone. My name is Kambiz. I'm from the School of the Built Environment, Massey University. So I am honored to work with the great team, Dr. Mostafa, my main supervisor, and Professor Suzanne, and Dr. Raymond, and Dr. Eghbal from the industry. We are running a very big project in terms of how we are going to simplify very challengeable topic in terms of the delays in the constructions, in terms of real-time technologies. So this presentation will be the part of that research. So in terms of that one, we are going to talk about how we are going to design and analyze real-time progress tracking systems, and test it in the smart category project in New Zealand. This is the nature of any project, especially in the construction and another especially during this pandemic. We have got a lot of the delays, and we are causing the project in terms of the delays, and a lot of the factor coming through in terms of the delay. But if we want to go through and narrow down that one, and get the framework and conceptual model in terms of that, we are going to focus on the productivity just in terms of the cost and schedule. Because these two items is very difficult to billing and actually monitoring and control. And we can say this is the intuitive concept. Another thing is very difficult and very concerned in terms of the delay coming from the contract side of view. But we are not going to talk about that one more because this is the phasing for talking about that. I had two questions from you, but I didn't have the time in terms of some words about the significance and no longer, but this word is coming to make another delay because our research is going to be quantitative instead of the qualitative. So it means we are going to understand how much we are behind the schedule, how much over the cost or budget. So because of that one, we need to play with the tangible data. So in terms of that big project, we went through to understand what is the objectives and the problems. A lot of the researchers and the literature reviews talking about the technologies, this technology, that technology, how we are using this one, how we are using that one, how we are going to the data acquisition, how we are going to the data fusion, how we are going to capture the real-time employee monitoring, and blah, blah, a lot of things. But the focus is on the process. How we are going to simplify this data-driven using the technology process from the data acquisition till data presentation. Why? To understand how we can go to mitigate delay as much as we can. So in terms of that one, we got a lot of the problem, but some of them is this. When we are using the technologies, most of them is significantly expensive. How much? We don't know. So this is time consuming. So it means less frequently perform on site. Communication facility. So we don't know who is responsible for data acquisition, who is going to report that one, who is going to analyze that one, who is going to wrap up that one. So who is going to deal with the client, who is going to the court of defense from the company in terms of the delays. And lacking the planning related to the productivity. We are talking about productivity. A lot of the items coming through, but now we're just focusing on the time and the cost in terms of that one. So the last one, but not least, is was having many different aspects coming through these items. So that's the reason we went through by the mega project in the New Zealand. As you see, this is the demo of that project. This is including the 27 smart construction project with the different scopes. But we went through and narrowed down that one for the just electrical and instrument trade. So in the electrical and instrument trade, we went through by the cabling and the cable trade. So we picked up the only 5 projects. So we named it A, B, C, D, E. So in terms of that one, we have this number of the cabling and cable trade must be done. So it means it came from the tender time. So it means this is the as planned data. So we are going to understand how we are behind this one and how we are over that on time of that. So through that one for designing the modeling, we went through by the 3 phases. The first phases, it means requirement and identification. It means we need to understand what is our requirement. And the phase 2, we need to understand what is the conceptual model, what is the relation between them. And the last one is the implementation stages. So the first one, we went through by the current situation, we understood the data coming from the slide, by the paper and photo, or we can say the home ground data, and then analysis, if delay, yes, if not, what's going on, and to. But the proposed that one is this. We are going to getting the data. So how This is another concept. So they are going to gathering all the data through the cloud base and went through and automatically and continuously analyzes this process. So in terms of that one, we use the UML model and the CPOC model to understand how we can get this one dynamic. That means how we capture the supplier, what is the input, what is the output, and what's the customer in this model, and what is the process. Because we are going to focus on the process to optimize that one. So then the next step of this one, we're focusing on the use cases. For the use cases, the model of use cases is going to analyze the behavior of the systems from the data acquisition to data presentation. Because the key stakeholders at the end, that side, has to responsible and accountable to present the project status. So in terms of that one, we need to keep our eyes through this process from the site to the end. So, end of the story, we went through and created our classes. Each of this big one is the classes, and under that one, as information is called the attributes, and the different colors shows about the primary key and the foreign key in terms of the database concept from view. So it shows how this project, such a big project, can be minimalized and can be optimized through this smart database and process, and how we can go through from this one to the end to get the real-time data and for getting the better decision. The achievement is this. After running the proposed one, we understood the report preparation time reduced from the 21 minutes to 12 minutes. And productivity tracking time during the data collection and accuracy is dropped from the 15 minutes from the 35 minutes. And installation about the recording is always unavailable. It means we have one listen-learn package. Is you can access to that one anytime you want. So finally, it helps the project decision maker update program and manage timely delay to deal with that one and find the solution on time. Thank you very much.
Thank you, Kambiz. It's a well-thought model and also a fantastic pilot test. Just would like to ask the audience if you have any questions to ask Kambiz. Is there any questions online? All right, yeah, so I might have one, Kambiz, about the model. Can you, well, I noted that it is a pilot, but is there any future developments of these models and how this can be maybe further applied into future projects?
Okay, yeah, we are going with the pilot study. Our pilot study includes the 35 smart construction projects. So we picked up the 5 of them. And for the testimony, we are going to apply the 5 to 10 another projects as a testimony to use this technology. This is the part of the big project we have. In terms of that one, we are going to introduce the 45 or maybe 60 to the world. How we are going to deal with that one and how we are going to simplify these very complicated topics as we understood the everyday going, every coming and introduce the new technologies, but think how we are going to these technologies properly. Having the technology is good, but most of the times the
Thanks a lot, Kambiz. It's a bold plan, and I wish you all the best in the upcoming studies. And thanks, Kambiz. So, audience, right now we have one hybrid session, so one last paper, and hopefully I'm very disciplined, so hopefully we can finish on time. And so we have Claudine in here, but I was just wondering whether Claudine, it's in here in person, if you could say hello to us. Have he logged in? No, then I think perhaps then we will just play, because we will also have audience online. So yeah, but based on it is also my very first hybrid conference experience, and so let's try it together. And so we would enjoy the video that Claudine prepared for us, and then after this, then we might need to raise some questions, maybe online, as I have already promoted that you can also go up to the Microsoft page and then type on your questions and see whether Claudine will answer us a little bit later. So right now I rely on Denny, isn't it? Yeah, to play.
Hello everyone, and welcome to this presentation entitled Building Related Data Structuring with Focus on Building Damages. My name is Claudian Gadezi. On behalf of my co-authors, I will be presenting you a little bit of our research. Today, in case I have a building damage, I know this building damage in my home, and my home it is insured, the whole insurance claim handling process does take currently a long of time. Does take a lot of money. That maybe the compensation is quite low, and generally it is not sustainable. So the whole process starts with the homeowner or the renter that it is claiming, it is registering the damage that has happened to the insurance company. The insurance company takes contact with an appraiser. The appraiser comes to my home and checks the damage, evaluates it, and in this case, it files a whole claim handling process. And if everything goes okay, then this whole process it is over. However, this holds all these different routes and all these different contacts, and they take a long of time, during to which the damage might develop even a little bit more. This whole process, it is quite costly if you think of how many people or professionals are involved and how much of time it is involved. And in general, this is not that much sustainable, especially if you think if I have a house that is in a remote place and one needs to come, one needs to drive over there. So a solution can be found to this problem, and one way it is to digitalize this whole process, or partly digitalize the process that involves all these different stakeholders. And one way to do that is by using an app-based. And the app-based, it can have a different level of digitalization. It can go from an automated registration of the damage by taking a picture of it, up to a full hand claiming process automation, where the person can take a picture of the damage, and then the whole process, it is fully automated, and it is and then the compensation goes directly to the homeowner together with the guidelines on how it should become. And there is a whole range of level of digitalization between these two levels that I introduced before. But what it is in common is that, considering that we have a lot of different types of building damages, a lot of different types of building materials, building elements, that these all are maintained or are operated in different ways. For everywhere you have different new products that are coming into market, which means that the complexity is very, very, very high. And in order to enable some machine learning algorithms to be trained to have the right amount of set of data, then we need to reduce this complexity. Otherwise, we would need a lot of training data in order to achieve the minimum requirement satisfactory probability of detection. And for that, we need to do what they all have in common is that it's quite a lot of it's a lot of so this research focuses on developing data structure that structures the whole information that is related to the building damages and how do they look alike. On the one hand, we structure the information of where the damage has occurred. And this is based on 5 main categories. The first is a type of building typology. In case we have an apartment block, or in case we have a detached house, most likely different damages might occur in there. We have different building zones, and it is the same. We have different building materials, different building elements, and risk spots, a new auxiliary category that helps us understand a little bit better where in the building element some damages might occur. So, as explained, first, it is the first category is building typology. If we have an apartment building, if we have detached house, different type of damages might be connected to different type of building typology. It is the same, the building zones as well. If we are talking about some wet rooms or some bathroom, and if we're talking about a rooftop, or if we're talking about a living room, a different type of damages might occur into different type of building zones. And similarly with the building elements, we have a lot of different type of building elements, and currently for this type of information, there are a lot of classification systems, international ones, that has tried to classify all the different type of building elements in current building. Then it is the risk spot, which is an auxiliary category that would help us understand a little bit better where in the building element might be places that typical damages might occur, and so on. Then we have different type of building materials that are currently used to develop different building elements in today's building practices. And in the end, we have the building damages. So in order to explain a little better what it means in practicality, how would this information be structured for a typical building damages, we show here, we have a case on fluorescein. The building damage is called a fluorescein. The related building materials that we can see here, we have the concrete on the bottom part, and the wood on the top part. The risk spot, it is at the intersection in the external wall where some material changes has occurred. As we can see here, we go from one building element to another by material change. So from timber into, or from wooden part to the concrete part. Then the building element that are involved here, it is a load-bearing external wall in this case, and it is an outside cladding and surfacing. Then the different type of building zones that are involved, we can see that the damage has occurred between the intersection between the outdoors and the indoors. And where the indoors has occurred, we have a wet room, a bathroom on the top part, and then a storage room on the bottom part. And then the type of building typology, in this case, it is a residential building, a detached house. So in this case, we have a whole, these whole 6 different type of categories provide a detailed classified information for this type of building damages or this type of occurrence. And then on this side, we had the information, the structure information related to where the building damage might occur. However, we might also describe the building damage itself through different variables. And those we have classified by the type of damage, the cause of damage, the time of damage, the detection of damage, the inspection of damage, the condition assessment, and the insurance as well. And for each of these, we have identified different variables with multiple choice answers that we can use in order to describe and to classify all these different damages that we have invented. For example, in this case, we have a failure mechanism that usually it can be a material damage, or it can be a form change or position change. We have the degree of the intensity, we have the level of hazards, and some physical features such as how it appears, its shape, its orientation, its color, and so on. And for each of these other different categories, we have also identified different variables. In all, this whole data structure comprises 55 different types of damages that are grouped and categorized in different ways depending on which variable we are using. These are connected to 128 different types of building materials that were identified that are typical materials used in the building industry, and then those are classified. Those are these damages are connected to 71 types of building zones that can happen in 35 types of building typologies. And then these damages are also connected to 150 types of building elements that are also connected 175 types of risk spots. And in all, we use 30 different types of variables with more than 800 different types of multiple choice divided into these other 6 different categories in order to describe and classify all these building damages. Thank you for your attention.
Yep, so thank you for the presentation. I would just like to check if Curtin is here. But noted that I think right now Norway is after midnight. It's very early in the morning, so I might not expect him to be there. Yeah, unfortunately, it's not there. And think well, it's a very fantastic classifications on identifying, you know, for our terms defects rather than damage. If damage, then I think about some compensations in money terms. In our terms, yeah, but a very fantastic model that he proposed. I think we are very disciplined. And so 2 minutes to go for the lunch. I think it's right now ready in the green ring that you joined the opening sessions this morning. So it's just across, for those who haven't been there, then it's just across the road, then you will see some facade, you know, like a, well, not very close to green ring, but green facade. Then you go in there. And then please enjoy your lunch. You know, I know that they promoted a little bit of that company, which I feel a little bit awkward, but I'm quite sure that they will have a good pick. So enjoy the time, and it's my pleasure to have the first sessions, and hopefully we will have a successful one today.